Welcome back to my YouTube channel. It's time to talk about the cloud. So the cloud can best be defined as software and services that run and are available on the internet. I have broken down the cloud and a few concepts into layers. So we'll work from the outside in. The cloud itself. In this example, we're going to look at the cloud as modeled by AWS or Amazon Web Services. There are many cloud providers. Each may use a different terminology for the layers, infrastructural components, etc. This diagram uses basic terms such as regions, availability zones, and subnets. This is a high-level abstraction of a complicated system of systems that enables the cloud to function as a reliable service. So to summarize, each cloud provider tends to use its own terms and meanings for various architectural components that comprise its cloud offering. However, the cloud, and I'm making quotes here, could be something as simple as having a single internet-connected computer for service of a website or backing up files. That being said, for the sake of this lesson, I'm focusing on enterprise-level cloud architectures. That is a design that permits services to be highly available, thereby playing to the strengths of cloud services. So let's talk about a region. As the cloud is hosted in various locations around the world, each of these locations is comprised of a region, so you can think of like continents. A region in turn is a collection of regional data centers, and typically each region is independent of other regions. So this is where the fault tolerance and redundancy of the cloud really comes in. Fault tolerance basically means if you have a failure in one place, you can move the service to another place. So if we'll take North America, for example, you have the United States East and the United States West. So on each side of the continent, we have a region. These are two disconnected collections of data centers basically. Having data stored in regions around the world permits the shortest physical path between regional users and the data stored in the cloud, as well as fault tolerance and stability. So if you are in the United States and you are on the far west coast in, say, California, there is a region in the west of the United States. It would make sense for you to consume services out of that region, as opposed to a region in Europe or region on the east coast of the United States. However, because of the nature of the cloud, and one of its strengths is that if the region goes down in the west, you could send that traffic and still serve it out of the east of the United States. So keep that model in mind, because we're going to talk about availability zones. Housed within regions are availability zones. These are data centers that comprise a region. A data center is basically a building where there are many computers, typically servers, hosted and operated out of. So you've seen pictures of racks and racks of computers and servers. That's basically a data center. So then multiple data centers make up an availability zone when we're talking about AWS nomenclature. While isolated, availability zones are typically connected to each other through low latency connections, so that you can have services in one data center or availability zone connected to another and they are able to communicate as if they were local, and this provides a more local level of fault tolerance and stability as data may be stored in multiple data center locations within the region itself. So we've worked our way outside from the internet in general, to a region, which is essentially a continent or a part of a continent, to an availability zone, which is the data center itself. These are a collection of data centers within a region. Now we have the subnet. The subnet is the local network instance for the compute resources in the cloud. So for the computer that is in the cloud, it has to be on a network. That network is the subnet. There may be multiple computer instances or virtual servers existing within a subnet, and these are replicated into additional availability zones in additional regions. That's a mouthful. Let's talk about that. We have multiple computer instances, and these are typically virtual instances, which is something we're going to cover when we talk about virtualization, but it's basically having multiple computers, or rather multiple operating systems installed and running at the same time on the same computer. So for instance, my laptop here may have Ubuntu running, which is what I'm in right now. It may also have Red Hat and running. It could have Mac OS running as well. All at the same time. One of these will be the host operating system and the others will be virtual operating systems or virtual guests. So we have these compute instances, our servers, if you will, our virtual servers in the cloud. We can replicate these or duplicate them into additional availability zones and regions. So we can have some in US East. We can have some in US West, and the reason we do this is in case one of them becomes corrupt or if there is a problem at one of the data centers. We have spread our resources around to create a very fault-tolerant or redundant service. This is often accompanied by automation mechanisms to create and manage a self-healing infrastructure. Linux provides 90% of the public cloud workload. So to summarize that the subnet is the local network for things running in the cloud. They may or may not be connected to the internet itself depending on what their purpose is. So we've worked our way from the outside in, all the way into the local network of the things running in the cloud. So what is the cloud? Put simply, the cloud is a collection of data centers providing compute, application, and storage services over the internet. Now, I kind of touched on a single computer being connected to the internet, being in the cloud. There are open source applications that allow you to build your own cloud, and those are something like that. This lesson is now complete. If you are new, please subscribe our YouTube channel, like, comment, and share. Thanks for watching.